Hello everybody, my name is Muhammad Tanjamba. I'm from Sriwijaya University, Indonesia. I'm talking on behalf of Siti Inayah Rizky Hasanah and Danny Matthew. In this opportunity, I will talk about our papers, dimensional reduction using singular value decomposition and principal component analysis comparison for clustering result of Indonesian language. This research, starting from the need to cluster Indonesian language journal papers. As we know, data derived from text documents contain many attributes or dimensions. So they are categorized as high dimensional data. In data mining, especially in clustering process, high dimensional data can be an obstacle because the clustering algorithm only work well on low dimensional data. Therefore, to improve the performance of the clustering process in high dimensional data, it is necessary to reduce the dimensional. We know that there are two methods of dimension reduction, which are attribute selection and attribute extraction. Of course, with all advantage and disadvantage of each method. So, from the two methods of the reduction, we want to know what is the difference between the results of high dimensional data reduction when we implement singular value decomposition as a attribute selection or principal component analysis as an extractions method in clustering process. So this is our methodology. We using K-means algorithm to cluster, and as I mentioned before, that we use SPD and PCA reduction methods, and to get the best cluster number, we implement K-means dynamic algorithm to know what numbers of K this is the best one, and then we record all the result, DBI, Davis-Boolean index, also the computation times of K-means and iterations numbers of K-means. And then the last one, we compare all of the results using statistical methods. Here the result of the K-means dynamics when we try to find which K numbers is the best one. In our result, we get this K numbers 7 is the best one. So in our next testing, all the tests using K equal to 7 in our test, which we compare the result of the k-means only compared to reduct by SPD, and after that clustered by k-means, and the last one is the reduction by PCA, and after that we clustered using the k-means also. The results was analyzed using statistical methods, which we are using the ANOVA, analysis of variance statistical methods, and compare the result. The tools that we use was SPSS version 24. In this analysis, we compare the DBI value, computing time, and also the iteration numbers. Okay, and here are the results, where we find that in DBI value, there are significant differences between the results. The significance value in the differences between the results, where we find that SPD significantly difference with the k-mean, but the PCA, although it was get a smaller number of the DBI, but statistically no differences significantly. Second, the computation time. Also, we find that the ANOVA results show that there are significant differences, yeah, where all of three were different significantly. It means reduction method, even though the SPD, yeah, or PCA significantly influence the computation times of the k-means. And the last one, the iteration numbers. Also, the ANOVA test shows that little bit significance differences. But a little bit confusing because some of them look similar, where SPD and PCA in one subset, but PCA and k-means also in one subset. Okay, the result in our research, we derive the data from the hundreds Indonesian language journal with total 8,250 words. We using k-means dynamic clustering to find the best number of cluster, which is 7 as an ideal k value. And then we carry out the testing several times, I mean 30 times in each clustering method. We using the analysis of variance, yeah, to compare the DBI value, the computation times, and the number of iterations. And the results, we find that reduction giving an impact to the clustering result, which all the observations, which are DBI index, iteration times, and iteration numbers, they are significant differences between reduction or not reduction. This is the comparison where here we see that dBi value drops very significant when we implement the k-means, yeah, which reduct by SPD, but when k-means implement reduct by PCA, they are a little bit smaller, but the differences is not significant in dBi. Also, the red one is the number of iterations, where SPD give the smaller number of iterations. But PCA also give a smaller number, but not too significant. And the last one in the time computation times, where SPD give a significant difference with the k-means only, but PCA is the worst because the time of computation is more higher than k-means only. So from here, we summarize that we understand that to improve clustering results, dimension reduction is needed. When we implement the high dimensional data before the data will be clustered. In this research, we determine the effectiveness of the clustering method indicated by the smaller dBi value, the faster computation time, and fewer numbers of iterations. And from here, we see that the dBi value after deducted by the SPD, given a better performance of 23.53% compared to k-means clustering only. Also, the computation time, they are a lower, yeah, in average of 0.132 seconds. And the number of iteration becomes less, on average 5 repetitions. In conclusions, we conclude that in our case, in our Indonesian language journal papers data, to reduce the dimension attribute more effectively when we using the attribute selection such as SPD than the extraction method. Okay, that's all for my presentation. Thank you very much for your attention. Goodbye.